Okay, so we're dealing with another free fall problem here. And the problem reads, a bottle dropped from a balloon reaches the ground in 20 seconds. Determine the height of the balloon if A, it was at rest in the air, and B, if it was ascending at a speed of 50 meters per second when the bottle was dropped. So, let's see. So the first thing we want to do is we want to write down the information that we're given, right? So the first piece of information is the time, right? It takes 20 seconds in both cases for the bottle to drop to the floor. So we'll write T is equal to, in fact, let me write it with another color here. We'll write T is equal to 20 seconds. Okay. Now we're also given two other pieces of information relating to the first and second scenario. Right? For scenario A, V0 is equal to 0. Right? This is the case where the balloon is just hanging in midair and it's not moving. So that's scenario A. For scenario B, V0 is not 0. Okay, in fact, V0 is equal to 50 meters per second ascending. So in this scenario, the balloon, the hot air balloon, is rising at a rate of 50 meters per second, and that's while that's when the bottle is dropped from the balloon while it's rising at this rate. Okay, so we're gonna separate these two cases. Let me write case A over here, and we're going to analyze case A. So for case A, we have the balloon. Okay, we have the balloon, and the bottle is dropped from the balloon while the balloon is at rest in midair. So V0 for the balloon is equal to 0. Now, since the balloon isn't moving initially, right, then obviously that means the bottle also isn't moving initially. It's also at rest with the balloon. So the bottle drops just to the floor, and we can write the distance. Remember, this is a constant acceleration problem, so we can write the distance formula for the bottle as y is equal to v0t minus 1/2 gt squared. But remember, there's an initial height for the bottle, so we have to add plus y0, right, where y0 is the initial height. Initial height. Okay, so y0 is the initial height, and that's how high the balloon was when the bottle was dropped. Okay. All right. So how do we solve this problem? Well, we do so just by plugging in the information. T equals 20 seconds, and V0 is equal to 0. So V0 equals 0, and after T equals 20 seconds, what we have, well, after T equals 20 seconds, remember, the bottle is on the floor, right? So if it's on the ground, then y here has to be equal to 0. Okay? So after t equals 20 seconds, y is equal to 0. So if we plug in these pieces of information, what we find is 0 is equal to negative 1/2 of gt squared plus y0, right? Notice there's no v0t here because v0 is equal to 0. So we can now plug in numbers for g and t. This is equal to negative 1/2 of 9.81 multiplied by 20 squared plus y0, which means we can solve for y0 now, and y0 is going to be equal to 1/2 of 9.8 9.81 multiplied by 400. Okay, so we find y0 to be 1,962 meters. Okay, so that's the answer for part A. Now, for part B, okay, for case B, it's a little bit different because the hot air balloon is rising. If the hot air balloon is rising at a certain rate, right, it gives us that rate, V0 equals 50 meters per second, then that means that the bottle is also rising with the hot air balloon. So the bottle's initial velocity is also 50 meters per second. Okay, so suppose that the hot air balloon is rising and the bottle is released from the hot air balloon. The trajectory of the bottle is going to look something like this. Let's say it was released at this point. Okay, so it's going to rise up a little bit and then fall down until it reaches y equals 0. Okay, so its initial velocity is directed upwards with v0 equaling 50 meters per second. Okay, so again we can write the height formula for the bottle as y equals v0t minus 1/2 gt squared. And then let's not forget the initial height from which it was dropped, right? So plus y0. Okay, okay. So here we have v0 equals 50 meters per second. We know that once it reaches the ground, y is going to be 0, and 20 seconds would have passed by. So we could say, again, after t equals 20 seconds, we have y is equal to 0. If we plug this back in, we have 0 is equal to v0t minus 1/2 gt squared plus y0, but we'll go right ahead and plug in the values for v0. So that's 50 meters per second multiplied by the time t, which is 20 seconds, minus 1/2 of 9.81 multiplied by 20 seconds squared, right? So that's going to be 400 seconds squared. I'll put in the units after we've calculated the numbers. So 50 times 20 minus 1/2, 9.81 times 400 plus y0, which means y0 is going to be equal to 9.81 multiplied by half of 400, that's just 200, minus 50 times 20, that's just 1,000. Okay, so remember we calculated 9.81 times 200 over here, right? So that gave us 1,962. So this is going to be equal to 1,962 minus 1,000. Okay, so we find that in the second case, y0 is going to be equal to just 962 meters.